48,000. I want you to just hold that number in your head for a second. 48,000 kilometers. If you were to lay that out in a single straight line, it would wrap entirely around the Earth, and you'd still have a few thousand kilometers left over. But this isn't just some hypothetical line. It's the real physical distance of high-speed rail track currently operating in China right now. It's a massive, almost incomprehensible number that represents a complete transformation of global infrastructure. And the craziest part? It happened in roughly 2 decades. Welcome to This Explainer. Today, we're taking a reverse engineering playbook approach to understand exactly how this infrastructure miracle was achieved. Because we aren't just going to look at the trains themselves, we're going to dig into the strategy, the funding, and the overarching blueprint that made it all possible. We're literally breaking down the steps from 0 to 48,000, so you can see exactly how the world's largest rail network was built from the ground up. Okay, let's dive into this. Here is the exact architectural blueprint we're going to follow. 1. The world's largest network. 2. The core building formula. 3. Standardizing the fast track. 4. Tragedy, safety, and resilience. And 5. Why others can't copy. Section 1. The world's largest network. Because a network capable of connecting most major cities definitely didn't happen by accident. Think about how most countries build railways. They usually look at 2 cities, find a route, build an isolated line, and maybe, years later, they start thinking about the next one. It's very much one project at a time. China, on the other hand, took a completely different approach. Back in 2004, when they approved their long-term strategy, instead of isolated routes, they essentially planned an interstate highway system for trains. They mapped out an entire national grid. They started with what they called the 4+4 corridor plan, which basically mapped out these massive vertical and horizontal arteries, like a giant tic-tac-toe board across the whole country. And that was later expanded into an even more massive 8+8 network. The key here is that they saw the entire board before they even started placing the pieces.
And their immediate priority? Connect dense city pairs. We're talking about massive hubs like Beijing to Shanghai, Guangzhou to Shenzhen, and Wuhan to Beijing. Now, you might be wondering why these specific routes first. Well, because they serve absolutely enormous populations. The sheer volume of passenger demand between these specific megacities generated an immediate, undeniable need. And it was exactly that guaranteed, built-in demand that helped justify the frankly unbelievable scale of upfront investment required to lay those first tracks.
Section 2, the core building formula. Let's look at the specific, step-by-step strategy they used to execute this. So you have the guaranteed demand and you have the master plan. But how do you actually put the steel in the ground? China used a highly structured 6-step formula, and this brilliantly illustrates the methodical nature of this massive project. Step 1, the national plan. 2, tech transfer. 3, massive funding. 4, standardized construction. 5, domestic innovation. And 6, relentless expansion. Literally every single kilometer of that 48,000-kilometer track relies on this exact sequence. Let's zoom in on step 2 for a second. In the early 2000s, China actually lacked advanced high-speed rail technology. But rather than spending decades developing everything from scratch in a lab, they instituted a very strict policy for foreign partnerships. Their mantra was introduce, absorb, improve, and innovate. They partnered with established industry giants from Japan, Germany, and France. But here's a catch. This wasn't just a shopping trip. Chinese firms were required to learn the tech, adapt it, and eventually manufacture it themselves domestically. They didn't just buy trains, they bought the knowledge. And over time, Chinese engineers modified these imported designs until they were building their own cutting-edge domestic train families, like the Fusing. If we lay all of this out on a timeline, the speed of execution is just staggering. The core strategy gets approved in 2004, but the real rocket fuel was added in 2008. During the global economic downturn, China's central government, state-owned banks, local governments, and railway entities unleashed a massive economic stimulus. We are talking about financing at a scale very few countries could ever match. It meant they didn't have to wait for one rail line to become profitable to fund the next one. They could build multiple, massive lines simultaneously. Now, we do see a tragic pivot point in 2011 with the Wenzhou accident, which we're going to discuss shortly, but the momentum ultimately carries forward, pushing toward a target of 60,000 kilometers by 2030. Section 3, standardizing the fast track, because physical construction had to match the speed of that funding. Even if you have limitless money, how do you physically build that much infrastructure that quickly without it devolving into total logistical chaos? Well, through sheer discipline. China didn't just standardize 1 or 2 things, they standardized almost everything across the entire country. We're talking about uniformly repeated train designs, identical station designs, universal track standards, standardized signaling systems, and replicated construction methods. By repeatedly using the exact same blueprints and processes over and over again, they created massive economies of scale. And the benefit of that? It dramatically reduced the cost per kilometer and vastly accelerated the speed of construction compared to how many other countries operate. To really wrap your head around this, think of it like this. It is exactly like building thousands of identical apartment towers rather than hiring a boutique architect to design every single building from scratch. Once you figure out the absolute best way to lay a kilometer of track or build a regional station, you just copy and paste that process across the entire continent. It is the ultimate industrialization of infrastructure. Section 4. Tragedy, Safety, and Resilience. Moving at this kind of breakneck speed carries profound risks, and it's absolutely vital to understand that this rapid expansion was not flawless. In 2011, near the city of Wenzhou, a devastating major train accident occurred. This was a critical and deeply tragic moment that shocked the entire system. It immediately raised incredibly serious concerns, both domestically and internationally, about the safety protocols, the management, and the sheer relentless pace of the high-speed rail rollout. The overarching question became, were they building too fast to build safely? The response to Wenzhou forced a major safety pivot. The system essentially hit the brakes. China conducted comprehensive, system-wide safety reviews. They actually went in and lowered the operating speeds on some lines just to ensure tighter margins of safety, and they significantly strengthened their oversight protocols. They had to systematically address the flaws in their execution before they could safely resume their aggressive building campaign. It was a very sobering reminder of the very real stakes involved in mass infrastructure.
Section 5. Why others can't copy.
Looking at the immense success of this network today naturally leads us to the question literally everyone asks. Why is this so hard to copy? If high-speed rail is so incredibly efficient and the playbook is out there for everyone to see, why doesn't every large country have a 40,000-kilometer network? Well, the answer lies not in the steel or the engineering, but in the underlying systems of governance and land management. So the crucial point is that China's playbook relies on systemic advantages inherent to its structure. They have strong central planning, which means a single, unified vision. They have state-controlled land acquisition, meaning they can route a train line exactly where they want it without decades of eminent domain lawsuits. They have state-backed financing, a massive construction workforce, and huge population density. Now, contrast that with most democracies. Democracies are designed to balance competing interests. That means much longer approval processes, shifting funding sources that change with election cycles, and extensive property negotiations. Because as anyone who has even tried to build a shed knows, local permitting takes time. Neither system is universally simple, but one is fundamentally optimized for moving quickly on a national scale. And moving quickly is exactly what they are continuing to do. By 2030, China targets reaching roughly 60,000 kilometers of high-speed rail. They transformed from having almost zero modern high-speed track in the early 2000s to a network that will soon span 60,000 kilometers. It's a true testament to the sheer power of long-term state planning combined with relentless execution, which leave us with a pretty fascinating dynamic to consider. As the world looks to the future of green transit and mass connectivity, we really have to ask ourselves, how do we balance the unparalleled speed and efficiency of state-controlled infrastructure expansion with the deliberate, consultative processes of democratic systems? What trade-offs are we willing to make to build the future? It's a massive question, and I highly recommend you keep it in mind the next time you look at a transit map.